Today is kind of like a review class. We're going to watch a Generation Genius video and take the quiz. And then we have an experiment for at home that you guys are going to do this weekend. Okay, everyone. Let's actually look. Let's see who did the best on their quiz for homework. I'm going to go for the quiz that you guys did for your homework. So we have 3 people with the top score. We have Daisy got number 1. Ray got 2nd place, and then Funny, Lucky or Bunny, but Funny got 3rd place. Good job. That's our 1st, 2nd, and 3rd. Good job, Daisy. And Ray, good job. You only did 1 attempt, and you came in 2nd. Very good. I'll keep on going. Milk, good job. A lot of people got 100%, which I'm really happy about, especially with 1 attempt. That's really good. Sino, Zook, Sophia, good job. 1 attempt and you finished it at 100%. Good job. Good job, Misha. Blue Moon, Puppy, Pasta. You guys did really good this time. Alex, 3-8. Your score gets higher the faster you complete it. The faster you guys complete it, the higher your score can get. So the score is based off your time as well. We had a few people that did not finish it, but everyone else that took it did pretty good. Congratulations to Daisy, Ray, and Funny. Good job. Okay, let's go. I just want to see if there's a missed question and I can help you guys with it, okay? The most missed questions were, what is the definition of force and what is the definition of pull? Those are the most incorrect answers. What's the definition of force and what is the definition of pull? Who can tell me the definition of force? Zook, what's the definition of a force?
A force is a push or pull.
Very good. A force is a push or a pull. A push or a pull. It looks like a lot of people answered is when you use a force to move a thing away from you. But what's the definition of a pull? Are you moving something towards you or away from you? Moon, what's the definition of a pull? Are you pushing something? Are you moving something away from you or towards you?
Towards you.
Yeah. Good job, Moon. Towards you. So those were the 2 most missed questions. Good job on getting 100%. Most of you guys did get 100%, but there were some missed questions. Okay, let's get into our lesson so we can take the quiz. Okay, share. Okay, let's watch. We're gonna watch the video.
Oh, hey everyone! Welcome to 3-2 Wonder. I'm Dr. Jeff, and today we're gonna study the science of pulls and pushes. Let's explore. Whoa! I'm okay. Today, we'll learn that a force is a push or a pull that makes things move. Pushes and pulls can be strong or weak. And pushes or pulls can change an object's motion.
3-2 Wonder!
Dr. Jeff, are you okay?
Yeah, looks like the punching bag won that round.
Oh, hey, Olivia. Hi, Elijah. I think my future's in science and not in boxing. Anyway, are you 2 ready to learn about force?
You bet we are.
Well, I hope you brought your tickets, because it's time to go into our imaginations. Follow me. Ready? Here we go. In 3, 2, Wonder!
Whoa! I can't wait to see how our imaginations help us learn about force.
I'll show you how. But first, let's remember that a force is a push or a pull that makes things move. To show you that, I'll need a shopping cart.
A push is when you use force to move something away from you.
And a pull is when you use force to move something towards you.
Excellent! We use pushes and pulls to move a shopping cart through the grocery store so we can shop for food.
Do you think next time you could imagine a shopping cart without a squeaky wheel?
And maybe one with some more snacks?
Maybe next time. Now, can either of you think of other examples of using force in our everyday life?
Oh, I've got one.
Okay.
If I want to score the winning shot, I have to use force to push the basketball towards the hoop. Booyah!
Nice shot, Olivia. You use force to push the basketball into the hoop. Can you think of an example that uses force to pull something?
I've got one. If I want to clear weeds from my yard, I use force and pull them from the ground towards me.
Yay! And then I have to use force to pull out the tissue to get it to my nose because of my allergies.
I totally get it. Forces can make things move.
That's right, but it's not all. Forces can also change the motion of things. Whoa!
So, if I want to change this ball's motion, I can use force to push on it, which makes it stop.
And if I want to change the ball's motion to be faster, I can use force for that too.
Nice. We know that a force is a push or pull, and that it can change the motion of things. Now let's go back to the lab and do an investigation. All right, we learned that forces make things move, but they can also be strong or weak, and they can go in different directions. To help us learn about that, we're gonna need a volunteer.
Oh, me!
You don't know what it's for.
That's cool.
It could be dangerous.
That's even cooler.
Okay, Elijah, you're gonna be a bowling ball.
No fair. I've always wanted to be a bowling ball.
Don't worry, you're gonna be the bowler.
Okay, I can work with that.
Elijah, put on these goggles and the helmet. Safety first. Here we go. Elijah, you can sit right on the platform. And Olivia, the bowling lane is yours. Using force, push Elijah into the bowling pins.
Wow, I'm not as good of a bowler as I thought.
Don't worry, Olivia. All you need to do is push with more force. How far you can push something depends on how much force you use. If you don't use enough force, Elijah won't go far enough. Using too much force could push him too far.
I'm okay.
I pushed with as strong of a force as I could.
You sure did. Remember that you also have to push him in the right direction.
But if I don't, can we use force to change his motion?
We sure can. Forces make things speed up, slow down, and they can also make things change direction. This time, use a strong force to send Elijah straight into the pins. If it goes to the side, I'll use another force to change his direction so we can score.
Yes! Booyah! Again!
That was awesome.
Olivia uses force to make Elijah move. Then I use force to change his motion. Strike! Now it's time to get hands-on with force.
Today, we're going to use force to push a ball through our homemade golf course.
You're going to need a stack of books, paper cups, scissors, some tape, a yardstick, and a golf ball.
First, design the shape of your golf course by placing the books next to each other.
Then, to create some fun obstacles, cut the bottom out of one of the cups to make a tunnel for your ball.
And tape it to the ground to keep it in place.
Then, take another cup and tape it at the end of the course as the hole.
Then, use your yardstick or anything sturdy enough you have, like a golf club.
Line up your shot and use force to make the ball move.
Try using a strong or weak force to push the ball.
Make sure to hit it in the right direction, too.
We got it! Try it yourself.
Pushes and pulls change how things move. Forces can go in different directions. Pushes and pulls can be strong or weak. Pushes and pulls change how things move. Forces can go in different directions. Pushes and pulls can be strong or weak. So when you push with force, things move away. They'll move back to you when you pull. Pushes and pulls change how things move. Forces can go in different directions. Pushes and pulls can be strong or weak. A force can change an object's motion. A stronger force makes bigger change. Pushes and pulls change how things move. Forces can go in different directions. Pushes and pulls can be strong or weak.
Now, let's review.
Today we learned that a force is a push or pull that can make things move.
Pushes and pulls can be strong or weak.
Pushes or pulls can also change an object's motion. And now you know. Until next time, I'm Dr. Jeff.
I'm Elijah.
I'm Olivia.
Always question, always wonder.
Okay, guys. Hopefully you guys enjoyed the video. We are now going to be taking a quiz. If you guys go to the chat, you guys will see the link for the quiz. I'll give everyone a chance to enter and then we will start. Yeah, there's 29 people taking this quiz. Okay, guys, let's start. Could you push or pull a door? Okay, Alex is in the lead right now. Ray and Sam are second and third. The answer was both. You can push or pull a door. Okay, let's go to our next question. Would you push or pull a weed out of the ground? I can show you the question. Thirteen of you guys chose pull, which is correct. Would you push or pull an elevator button? Would you push or pull an elevator button? We're taking it together. Okay, right now Ray is in the lead, Pasta is second, and Scart is third. Good job, you push the button. Let's go to the next question. Nam, Susu, Jack, Alex, make sure you're answering. Puppy, could you push or pull a shopping cart? Okay, Ray and Scar. Good job. Okay, next question. Would you push or pull a button on a computer?
Push. Yeah. Push.
Okay, time's up. Ray is still first place. Scart and Sam are second and third. Would you push or pull a tissue? Pull is correct. Good job. 4 people chose push, but pull is correct. Next question. Which object needs the strongest force to move it? Well, Misha now is in third. Misha is now in third. Yeah, the house is the heaviest, guys. Which object would not need a strong force to move it? An elephant, a feather, a pizza, a desk. Okay, time's up. Ray is still in the lead. Sam, you're in second. Misha is in third. Good job, guys. It is a feather. Which thing would you need a strong force to pick it up? Is it a penny, a shirt, a soccer ball, or a cow? 2, 1, 0. Okay, Taylor got to 5th place. Good job, Taylor. 13 people chose the cow. Good job. Okay, which type of force could make a ball go really far? A strong force, no force, a weak force, or a little force?
Force. Little force.
Uh-oh, who said little force?
Not me. Strong force.
It's a strong force, yeah. Okay, that was the last question, guys. So let's see who's our winner. Ray got first, Sam got second, and Misha, good job, you got third. And then Alex got fourth, and Taylor got 5th. Good job, guys. And a lot of people did not answer. Okay, guys, so we have an at-home experiment. This is your homework. So what you need to do is you need to fill out the data collection worksheet, okay? But let's look at the experiment first, and then I'll show you the worksheet. But I'll show you real quick. So at home, you're going to need to find a toy car. If you cannot find a toy car, use something that is round. Use something that is round and you can push on the floor. This is how you should set up your experiment. You should have a piece of tape as a starting line and then put your toy car behind it. You are then going to push it with different amounts of forces. A little force, a medium force, and a large force. You then are going to use the ruler or measuring tape, and all you have to do is measure how far the car goes in centimeters. This is how it should look. The car goes behind the tape, and you push it, and you have to measure with a ruler or a measuring tape. Okay, if you're not able to print, you can type it. So everyone's gonna get sent this worksheet, and you'll be sent this link, and you can type right in here. I can type right now. You can type right here. See what you're gonna need. You're gonna need a ruler, a toy car, and a piece of tape. The directions are right here. What you need to do is write down what you use. So you could write down toy car. You would write that down. You could also write down the type of floor you have. Is it a wood floor, a wool floor? What type of floor is it? Is it made out of stone, wood, carpet? And then you push it with a light force, small force, medium force, large force, and write it down in centimeters. I then have discussion questions. What amount of force caused the toy car to travel to the furthest distance? What amount of force caused the toy car to travel the least amount of distance? Do you think the type of floor changes the distance the car will travel? If so, how? What would happen if you tried this in grass? Okay, and then you'd write your conclusion using these discussion questions. Does anyone have any questions?
My floor is made out of rough wood.
Is it made out of wood?
Yeah.
Yeah. A wooden floor is probably the best floor to do it on. A wooden floor or a stone floor. Any other questions? If not, that is it for today, guys. We'll send you this worksheet. And remember, you can do this at home. You're supposed to... Okay, if there's no more questions, bye-bye, everyone.
Bye, Mr. Connor.
Bye-bye, guys. Have a good weekend.